Hello everyone, welcome to Informatica support videos. This is Sarthak for Informatica GCS. In this video, I am going to discuss on CDI-PC or Cloud Data Integration for Power Center TLS configuration. Agenda for today's video are TLS support for CDI-PC domain, TLS configuration for CDI-PC domain, TLS configuration for DMA or Domain Management App, TLS configuration for CDI-PC client. Now, TLS support for Power Center versus CDI-PC. So we can configure two types of domain. One is TLS or SSL domain, the other is non-TLS domain. Now TLS domain can be further divided into two types. One is default TLS domain. When I say default, that means the domain is enabled for TLS using default certificate in keystore and trustor files shipped by the Informatica installer. On the other hand, custom SSL or TLS domain means that the domain is enabled for TLS using either self-signed certificate or CA-signed certificate. When I say CA-signed certificate, it is signed by some certificate authority. Power Center supports all these three categories. A Power Center domain can be non-TLS, TLS with default certificates, and TLS with custom certificate. But on the other hand, CDI-PC supports only custom SSL domain. That means a CDI-PC domain can be enabled for TLS only using either self-signed certificate or CA-signed certificate. Non-SSL domain is not supported for CDI-PC and default certificate are not supported for CDI-PC domain. TLS configuration prerequisite. So before a user configure a CDI-PC domain, he should make sure he has these files available for the configuration. So first step is generate Infa keystore JKS, Infa keystore PEM, and Infa trustor JKS and Infa trustor PEM for CDI-PC domain TLS, and Infa keystore.jks can be used for CDI-PC admin console HTTPS. Okay. Step 2, generate keystore.jks and trustor.jks for secure agent. Now CDI-PC domain is TLS enabled. Similarly, from the secure agent side, the DMA has to be TLS enabled. For the DMA to be TLS enabled, we need two files, keystore.jks and trustor.jks. Here PEM files are not required. And the third and the most critical step is, once the files are generated, we have to exchange the certificate between CDI-PC domain and the secure agent trustor.jks file. Here the certificate has to be exchanged only for the trustor.jks, not under trustcore PEM. Okay. Now the fourth step is, once we have all the files handy, then we have to integrate or use those files to configure DMA for TLS. Then the next, configure CDI-PC domain for TLS and admin console for HTTPS. While creating the keystore and trustor files or requesting for the certificate, the user should keep point number 6 in mind. In CDI-PC, we verify host name in certificate during our validation. Okay, so the certificate must have the common name as the host name. Common name is nothing but the CN, and SAN, subject alternative name, is a mandatory parameter for CDI-PC certificates. So when you are requesting for certificate for CDI-PC, make sure SAN is a part of the certificate entry, both for CDI-PC domain and the domain management app. And the SAN entry must contain alias name of the host name, that is the short name of the host name, the fully qualified host name, and if your security allows, IP address of the host. Let's take an example. If the server host, either CDI-PC server host or the secure agent server host, the host name is your host name, then the fully qualified host name is your hostname.domainname.com and the IP address is XYZ. Then in the certificate CN common name, you should enter your host name, and in the SAN it should contain, compulsory should contain your host name, that is short name of your host, and fully qualified host name And IP address, again, it's optional. If it is allowed, you can add it, else you can skip it. Okay. And we know CDI-PC domain supports CSIN certificate or self-signed certificate. No other type of certificates are supported here. Okay. Now we know the prerequisites for the CDI-PC domain. Now the next step is how a user can get the certificates. So as I said, there are two types of certificates supported, self-signed and CSIN for CDI-PC domain. So if a user goes for self-signed, then the user can generate the 4 files, inpa keystore.js, inpa trust.js, inpa keystore.pem, inpa trust.pem for the CDI-PC domain, and for the DMA they can generate keystore.js and trust.js. But only thing to keep in mind, while generating the self-signed certificate also, you should make sure SAN entries is part of the keystore and trust store, and in the SAN we have a host name, fully qualified host name. And the next is CSIN. CSIN means certificate authority signed certificates. Okay, so to get a CSIN certificate, the user first has to generate a CSR. So CSR is nothing but certificate signing request. Imagine a user has 2 nodes and 1 secure agent. So, and they want to keep unique certificates for all these 3 hosts. Then in that case, user has to generate the certificate signing request for node A, node B, and for secure agent. And while generating those, SAN should be part of that with host name and fully qualified host name. Once the certificate signing request is completed by the user has to submit this CSR to the certificate authority. Now the certificate authority can be internal to the user organization, or it can be some external third-party well-known CS. So based on the CSR request, the CA will sign the certificate and give user back the complete chain of certificate. When I say complete chain of certificate, the certificate chain includes root, intermediate, and the public key or the host certificate or the server certificate. Once user gets all the chain of certificates, then using those certificate, user has to convert those certificates into key store and trust store, and the conversion has to be done for node 1, node 2, and secure agent. And once the conversion is completed and user has all the required JKS and PEM files, then the most important part that user has to perform, exchange the certificates between secure agent or the DMA truststore.jks and CDI-PC domain truststore.jks. Once the certificate exchange is done successfully, then the user can integrate those with the CDI-PC domain and DMA. Okay. Quickly take a look at the custom TLS architecture, what we discussed just now. So in this diagram, if you see the left hand side, it is the secure agent on which the DMA or the domain management app resides. Now, and on the right hand side, we have a CDI-PC domain which consists of node 1 and node 2. Now the secure agent has its own certificate and the private key, which is labeled in blue color, and on the right hand side the CDI-PC domain has its own certificate and private key. Now I was talking about the certificate exchange, so the green color suggests now the secure agent trust store also have the CDI-PC domain certificate chain, root, intermediate, and the server certificate, and the vice versa. And the CDI-PC domain, when I say domain, if you are n number of nodes, all the nodes should have the secure agent or the DMA certificate chain, root, intermediate, and the server certificate. And in the other hand, we have the thick clients, that is nothing but the CDI-PC client. Now the CDI-PC client, to communicate with the TLS enabled CDI-PC server, also needs to have the complete certificate chain to be present on the CDI-PC client machine. That we will see in the upcoming slides. Okay. As certificate exchange is the most critical part for the CDI-PC TLS configuration, so I will dedicate some time here to explain this. So and this is for CS-signed certificate. Self-signed certificate also same thing, but that is less critical because there it involves only one certificate. So I have taken example of CS-signed certificate here. So here if you see, I have considered, imagine a CDI-PC domain have two nodes, node 1, node 2, and have one secure agent. Now node 1 host name is, as an example, host name is 01, and fully qualified host name is 01.infa.com. On the other hand, node 2 host name is 02 and fully qualified host name is 02.infa.com. Similarly, secure agent host name is SA and fully qualified host name is sa.infa.com. Okay, now node 1 and node 2 and the secure agent. So I want to keep all the certificates unique for node 1, node 2 and the secure agent. So in that case, and the infa trustor.jks file of node 1 has cn equals to 01 hostname and SAN entry, this is the SAN entry DNS, which contains short hostname and fully qualified hostname. Similarly, for node 2, the CN will contain 02 and SAN will contain 02 and 02.infa.com. For secure agent, CN contains SA, that is the host name, and SAN contains short name of the host of secure agent and the fully qualified host name. Now this is the content of CN and SAN for the certificates. Now node 1 will have its own infa keystore JKS, node 2 will have its own infa keystore JKS and infa trustor JKS. Similarly, secure agent will have its own keystore and trustor JKS file. Now what is the content of node 01 infa keystore.jks? If you see here, node 1 keystore.jks contain private key. For just for naming sake, I have given it 01. Then root, intermediate, and the server certificate of node 01. Now the server certificate and private key are unique to this node. Root and intermediate for an organization, it remains same. Usually it remains same. Similarly, for node 2 has its own private key, root, intermediate, and its own server certificate. Secure agent has its own private key, root, intermediate, and server certificate. Now this is the content of infa keystore JKS or node 1, node 2, and the secure agent. Now for infa trustor.jks, node 1 contains root, intermediate, and server certificate. Now as we know, trustor is keystore minus private key. So trustor contains only the certificate chain without any private key. So the trustor contains only the chain of certificate. Now the content of node 1 trustor is root, intermediate, and server certificate. Node 2 is root, intermediate, and server certificate that belongs to node 2. And the secure agent has root, intermediate, and server certificate that belongs to the secure agent host. Now this configuration or the content is before the certificate exchange between the trustor of JKS of secure agent and the CDI-PC domain. Now let's see. Now I have performed the exchange of certificate and what contents are changed. So after certificate exchange, so if you see, infa keystore JKS is unchanged for node 1, node 2, and node 3. The content remains the same because whatever certificate we have exchanged only for the trustor JKS, not for the keystore. Okay, now if we take a look at the trustor JKS, we see root, intermediate, server 01 for node 01. These were there before. Now what additional certificate I have? Server 02, that means node 2 certificate is imported into this, and the secure agent certificate. Similarly, for node 02, root, intermediate, and its own server certificate were already there, and it has additional entries of server node 01 certificate and the secure agent certificate. And the secure agent has root, intermediate, its own server certificate, along with that server certificate of node 1 and node 2. Now the certificates are successfully exchanged among the trustor.jks file of node 1, node 2, or the CDI-PC domain and the secure agent. Now secure agent and CDI-PC domain can successfully communicate or do a handshake with each other. Okay, here one thing we need to keep in mind: secure agent certificate are not required to be imported into infa trustor.pem file. Okay, it is only required in infa trustor.jks file. Okay, now to import the certificate, user can use keytool import command. This is the sample command I have given here to do the certificate exchange. Okay, now we have the required key store, JKS and PEM file available for CDI-PC domain TLS configuration, and required key store and trustor JKS file for the DMA TLS configuration also. Certificate exchange is already completed. Now it's time to enable CDI-PC domain and CDI-PC admin console for HTTPS. So the steps still remains the same like Power Center. So first step is we have to enable TLS at the domain level. So for that, user have two choice. They can use the infacmd command while the domain is up and running, or they can go to admin console, login, and from admin console, the node properties, we can check the box enable secure communication. Sorry, correction, domain properties. Enable secure communication has to be checked. Once that is done, then the domain is TLS enabled. Now the CDI-PC domain has to be shut down, and then we have to go for the node level TLS enablement. For that, we have to execute infa setup update gateway node. Okay, in this command we have to pass -tls true. -nk is the node key store directory. That means the path where the node key store file is available. Here file name is not required. -nkp is the node key store password. -nt is the node trustor file directory only, not file name, and ntp is the node trustor password. -hs is the HTTPS port to enable admin console HTTPS. Here you have to give the HTTPS port number. -kf is the admin console key store directory along with file name. Here we have to pass the path where the key store file exists along with the name of the file. If the name of the file is infa keystore.jks, then we have to pass infa_keystore.jks, and -kp is the password for the admin console key store. Now in a domain, if you have multiple gateway nodes, then we have to run this command on all gateway nodes. And if you have worker node, then we have to run the below command infa setup update worker node across all the worker nodes. Once these commands are run successfully, now CDI-PC domain is configured with TLS. Now the domain can be successfully started. And in the other hand, to configure DMA for TLS or secure agent DMS service for TLS, we have to follow this step. So you have to log into IDMC console, click on the administrator chiclet. Once you log in into that, select the runtime environment, then select the secure agent which you want to configure with the CDI-PC domain. Once you select the secure agent, it will land you in this page. Then click on the edit button on the right top. Once you click on the edit button, then select system configuration details. Under service, select domain management app. Under type, select security_CFG. Okay, once you select this, below you will see these 4 names. So DMA keystore, DMA keystore pass, DMA trustor, DMA trustor. So here you have to give the path and the keystore file name. Below, keystore password, and next you have to give the trustor path and trustor file name and trustor password. Now this file has to be present on the secure agent machine, and the path and the file name have to be given correctly. Once you enter these details, and here where save button will be enabled, click on save. Then what secure agent will do, it will spawn a new version of domain management app. Once the new version of domain management app is spawned and the DMA is available, now your CDI-PC is TLS enabled and DMA is also TLS enabled. Now the user can register the CDI-PC domain into DMA or the secure agent or the cloud successfully. Once the registration is completed successfully, they can log into admin console. Now that we have enabled the CDI-PC domain for TLS, so the CDI-PC client side also some TLS configuration is required, so that CDI-PC client can successfully communicate with the TLS enabled CDI-PC server. So to do that, what we have to do is we have to copy only the infra_truststore.pem file from CDI-PC server and place it in some location on the CDI-PC client Windows machine. So now the client to know which file, the truststore file I need to read, we have to set an environment variable infra_truststore equals to the path where the infra_truststore.pem file is placed. Here file name is not required, only the path to the file. Once the environment variable is set correctly on the Windows machine, then the client can be closed or stopped and again restarted to pick the environment variable. Once the client pick the environment variable, you can successfully connect to the TLS enabled CDI-PC server. Okay. Now there could be a scenario where a customer want to connect from one CDI-PC client to multiple CDI-PC servers. For example, development CDI-PC server, QA CDI-PC server and production CDI-PC server from the single client. Okay, so in that case, what the user has to do, user has to merge all the certificate, server certificate into existing client infra_truststore.pem file. Okay, let's take an example here. So initially user was able to connect to the QA CDI-PC server, and so what was the content of the CDI-PC client infra_truststore? Root, intermediate and server side. Only these three files were there. Now from the same client, user wants to connect to development also and production domain also. So in that case, user has to go to the development server, copy the only the server certificate and append in the existing truststore.pem file to the client side. Similarly for production, server certificate has to be copied and appended. Once the files the certificates are appended successfully, save the infra_truststore.pem at the client side, and after that just stop and start the client again. Once the client is restarted, we can successfully connect to all the three TLS enabled CDI-PC domains from the single client. If you have multiple users connecting to the CDI-PC server from different Windows machines, then the same step have to follow. Or maybe the user who has already configured this can share this truststore.pem file for all the users. They can place it to a location and make sure this environment variable is correctly added. Once it is done, then the users can connect to the CDI-PC server from CDI-PC client successfully. Okay. With this, we have completed TLS configuration for CDI-PC domain. We would love to hear from you. You can provide your feedback by visiting supportvideos@informatica.com. Also, you can write us on Twitter. Thank you for watching this video.